Hello, welcome back everyone. Is the thing too loud? Is it too loud, people in the back? Seems all right. It's all right? Cool. Okay, so as you might have heard, we have our first term test next week. Ooh. Yeah, actually, yeah, let's just leave it at that. So if you're in this section, it'll all be great. It'll all be fun. You guys are so ready. If you're in the other section, I have no idea. So I posted an announcement on Quarkus yesterday, sort of outlining how things will run. So for people in this section, we'll be writing our term test a week today. Okay, so we've got 168 hours until term test 1. So 1 week today. We're covering all the material except the business about polar area. Okay, so right. Also arc length and polar area. So 1.4. I don't feel like we're ready to do 1.4 yet, so we just won't do it. So 1.4 is area and arc length and polar coordinates. So we'll pass over this. Yes, yes, and we'll talk about what it includes. And the material today is absolutely 100% on the term test. Okay, so today is fine. Next Wednesday's lecture will not be on this coming term test. Okay, so today is testable. Next Wednesday will not be, and the next Friday we write the thing. For what it's worth, the cover of the term test looks like this. Okay, so this specifies all the usual rules. You know, please, no calculators, no laptops, no smart watches. Anything that can send or receive electronic signals, we want to minimize. There's always that one guy who brings a vibrating coat, who's got like some cool thing where he does this, and then it Morse codes to his friend, and then, okay, so please, no weird Morse code jackets, okay? Very good. Please no cell phones. The setup of the term test is like this. There's 8 multiple choice questions. These will usually be like, identify a graph, right? It'll show you a graph. Which of the 4 functions is it? Or, it'll give you a point in polar coordinates and say which Cartesian point is it, right? So there's 8 of those. There's 3 short answer questions. These are sort of similar to what you've been doing on your quizzes. So these are going to be, like 1 quiz question is about 1 short answer question. Okay, so that's sort of the level of difficulty. And then there's 2 long answer questions, which are sort of multi-stage calculations, right? Like, for example, in a lecture, we did this big example with a cycloid, right? It took us like lots and lots of blackboards. That's the kind of thing that we can expect to see in the long answer. Right, so there's that. Yes. Okay, so we'll be writing a lecture in this room next Friday. The absolute best way to prepare, I got lots of emails saying, what can I do to get ready? Are there extra problems that I can solve? The best guide to what to expect is the readings. Okay, so if you do these, if you read the examples and you can solve the exercises, you'll be good to go. If you want more exercises, I want you to bring your notebook full of these first. Okay? If you bring me a notebook where you've solved every single problem, then I will give you more problems to do. But start here.
So was like finding like partial derivatives or something considered a long answer or a short answer?
When finding a partial derivatives would be short answer. For people who don't know what partial derivatives are yet, we'll figure it out momentarily. But yeah, so that would be a short answer. Any other thoughts or concerns with the term test? Hello. So I think we've got this. I think we're almost there. If you want to ask additional questions, if you're curious about something, but don't feel like speaking up now, there's an anonymous feedback form on the announcement, so you can click there, say that you're in 232, and you can put your question or concern about the term test there. So that's available. There's a short video announcement. Okay, excellent. Okay, so I want to come back, talk a little bit more about contour plots. People often find contour plots quite confusing, so I want to go over a couple more examples of contour plots. So the main idea of a contour plot is that we're cutting our surface into levels and looking at those levels. So So a level set is the set of inputs that outputs a fixed constant. So this is all of the xy such that f of xy is equal to k. Okay, so a level set is all of the points that output the same height k. So I want you to take a moment and stare at your hand again. Okay, hold your hand in this position, up with the fingers pointing upwards. And now stare at your hand and imagine what it would look like if you graphed out the different heights of on your hand. Okay? So if you look at your hand, you'll see that it starts with a bunch of small points. Right? So your hand will look something like this. All right, there's your middle finger, that topmost tip. And then you'll get something like this. There's your index and ring finger. Then you'll get your pinky finger. Then at some point, these will all merge together. Okay? Can anyone actually see this when they're looking at their hand? Do I get some like, yes, we see this? Or no, we do not see this? Right, so stare at your hand for a moment and imagine those different levels. Okay? Then at some point, your thumb would join into the picture. This would all stay as one thing. Your pinky would still be here-ish. I'm a mathematician, not an artist. Okay? And then eventually at the bottom, it would all join up. And then it'd be your wrist. Okay? That is a level set decomposition of your hand. Okay? And that is my right hand. So these are all at different heights. Okay? We can put our hands down now if we've seen it. People use this description of functions to draw maps. Okay, so this is a landscape feature, and this is a decomposition of that feature into different level curves. Okay, so these are the level sets of the height function. So notice how at the top of this thing, it's mostly flat. At the top of this thing, it's mostly flat, right? And this is all the same level curve, right? It's all just one big curve because that whole part of the tower is level, it's flat. And then these orange curves circling around are telling us that the height's changing. Oh, you guys missed the fun Sunday school thing. Oh, it's all right. This will be very confusing to these people. It's very hard to reconstruct this object. Okay, so this is a level curve decomposition of a 3D shape. Okay, so we're going to play around with this. We're going to do a couple more examples of drawing level sets for easy to understand mathematical functions. So we're specifying a list of numbers that will be our level sets, and we want to draw the level sets of this 3D function to understand the 3D graph as a two-dimensional picture. Okay, so the k equals 0 level set we've got a sum of things. We're saying that sum of squares should be 0. The only way that's possible is if xy is 0, 0. Okay. Now we start to get into the level sets that have lots of points in them. So for the k equals 1 level set, we want to figure out a little bit of what this thing looks like. So we will find its x-intercepts and y-intercepts. To figure out the x-intercepts, we set y to 0. And we get plus or minus 1. Okay, so we have on this level set those 2 points, and now we'll find the y-intercepts. So we set x to be 0. We solve for all the y that make this possible. Plus or minus 1 over root 2. Okay, and we get sort of an ellipse. Okay, so this level set has infinitely many points in it. It's kind of elliptical shape. This level set only has 1 point in it. It's kind of special. take, let's say, 2 minutes and try and draw the k equals 2 level set. So take 2 minutes, try and draw that thing on your own, see what it looks like following the k equals 1 extension. I used to say everything's easy, and then people will be like, "No, it's easy sometimes."
Because some of the textbook ones, like some of the graphs, like how it's completely curved, easier to visualize, like something like someone who's how
The test that we sent.
Yeah, it'd be very nice, straightforward.
Like, okay, I should say it would be a high school level. If you drew curves in grade 12, it'd be like, okay. Yeah, it'll miss somewhere in the circle. Yes. That sounds right.